So in today's tutorial, I am going to teach you design of gusset base for a column. First thing what you need to do is 0.45 FCK, meaning 0.45 into FCK, which is 20 M20. So here is the 20 will be FCK. 0.45 into 20, we get 9 Newton per mm square. So we have to provide area of base plate. Since we have to design a gusset base, then we have to find first area of base plate. So A equals P divided by 0.45 CK, which is 9. So P here is, make sure that your load is factor load. If it's not factor, multiply by 1.5. Here it is factor. So in Newton, it will be into 10 raised to 3 divided by 9. We get the answer in mm square. So now what we need is size of base plate and gusset. So first, what does that mean? Meaning length and width. So assume 60 mm side, 60 mm thick gusset plate providing on two flanges of column section and gusset angle 150 by 150 by 15 mm. And for this assumption, where this assumption come from? Well, this is the assumption comes from the thumb rule. Most of the time we provide this size, so any numerical you are trying to solve in exam hall, you can just use this, and you can, if you just use this, another calculation that comes after this will be somewhat similar to it. That will provide you something easiness. Now length of base plate L has a formula H plus 2 into cover plate thickness plus 2 into 60 plus 2 into 16, which is assume 60 mm thickness of gusset plate. If you assume something else, it will be different number here, plus 2 into this 115, which is a braid in here. This is length braid thickness. So formula comes around as H, which is 400. So we are given the H here, ISWB 400. By that we just use that height H 400 plus 2 into cover plate thickness. Now what is the cover plate? Here it will have the cover plate given. This is 60. So that 60 here plus 2 into this 60, that we just assume thickness of gusset plate. If you assume something else, you are going to write that something else, plus 2 gusset angles braid, which is 150. You can just choose this value. If you choose that, most of your calculation will be somewhat similar to this equation, this whole question. So adding all of them, we get 694. So use 700 mm wide plate. And always, if you just make sure that your value is 700, then the next answer that comes after this, the next calculation, they will be similar to this. And you can save them on a calculator as well. I will have make a video on how to save unlimited value on a calculator, which is this calculator. You can use this calculator to save unlimited value. I will make a video, you can check it out. Now width of base plate. Now what is a width of base plate? So A by L. So now area that you have calculated A, by length we have provided L. So dividing them 400, and make sure that if your value is something like 300, still provide 400. If it is more than 400, only then change it, because I will explain later that why providing this 7 by 400 will give you easiness in the calculation. So here now what you need to calculate, bearing pressure of concrete on base plate equals P by A1. So P as is given P 2500. A1 is the area that we have provided 700 by 400 mm, and we get the answer 8.92, which is smaller than 9. What is the 9? It is bearing pressure on concrete. It should be smaller than that. And now thickness of base plate. We have to find the T here, which has a formula C1 into in root 2.75 W divided by Fy. So for this formula, first we need to calculate C1, and C1 has a formula L minus H minus 2 into cover plate thickness minus 2 into this 15. So as for this 50, it is from here, as you can see, they assume thickness of two gusset angles. So if you assume something else, you have to choose something else. That's what I said. Always use this statement. Just copy paste this statement in your exam paper. So you get the L as you have provided, length, height, not this breadth, it is this height, ISW B 400. So that's why H 400 minus 2 into thickness of cover plate. We have cover plate thickness given 16 mm minus 2 into 15 divided by 2. We get 103 mm. That's the C1 here. Into in root 2.75 into W. What is the W? Is this divided by 250. We get the thickness as 75, 32.26, which is round up as 35 mm. Now thickness of base plate, that is the total thickness, but we need the thickness of base plate, which is 35 minus 50. This 50 comes from here, and the 35 minus 50 equals 20. So provide the base plate of 700 by 400 by 20 mm size. Now what you need is design of anchor bolts. And if you use this 20 here, you can actually change it, but you can just choose any value here as 35, as you can use a 40, 50. It just depends on you. No much worry for that. Now design of anchor bolts. Holding down base plate by 4 number of 20 mm diameter anchor bolts of length 300 mm length into concrete pedestal. What does that mean is you have to hold down a base plate. This is like a base plate that we have to hold down. So for that we are going to use a 4 number of bolts which has 20 mm diameter, and their length is this length of their bolt. This length of bolt will be 300 mm into concrete pedestal. See, this all will be displayed will be in concrete pedestal. You can copy paste this statement and your next calculation will be even more easier. Now what you have to determine is design bolt connection. You have to design a bolt connection, meaning VDSB and VDPB is what we need to calculate. So first the design shear strength of bolt, which is VDSB, equals ANB into N into in root FUV divided by root 3 gamma MO. As I said previously, that if you just choose this section, choose this copy paste in exam hall, then this answer that you calculate is really difficult to calculate manually. You just have to write down the formula and answer will be 58.04. And if you try to calculate it, solve it, it will take around 10, 20, 30 minutes depending on your capacity. So I would suggest don't bother up with this. Just round up value to the 700. Even if your value is like 500, 600, doesn't matter. You just have to round it up. It's up to you what value to choose for length, breadth. And also for this one, this is totally up to you. Use this section. No one is going to deduct your marks. And the next calculation, design bearing strength of bolt, is also going to be easy. All you have to do is write down the formulas, and the answer is 95.12 kilonewton. So both are in kilonewton. Now what we need is you have to choose the minimum value of them, which will be 58.04, and assuming 50% of load transfer by the connection. So 50% load is transferred by these connections, then P divided by 2. And since our previous answer was in kilonewton, we need this P as in kilonewton as well, divided by 2, and then divided by the minimum of previous two, which will be 58.04 VDSB and VDPB. We get number of bolts as 21.53. Always round it up to 24, so that when you do this figures here, this figure and this figure will be same. So in that case, what you need is 150. Instead, you can actually calculate all of this, but when you try to calculate everything manually and you have like 2-3 hours for the exam, it's really difficult. So just use this rounded up values, and it's 250. This figure, there is nothing changed except for this 500 and 700. As I said previously, that providing the length 700 by 400 mm, here is 700, and as for this 500, it is determined by the number of bolts you have. So just choose 24 always, and you will get the 500 value, and here is 700 value. As for this 40, 60 and 150, they are the same. If you choose a value that I recommended in the rounding up, then you will get this figure same to same with no change whatsoever. You just have to draw this figure and this figure of gusset pace, and that's your final answer. And also you have to use the statement here: provide 12 bolts or 20 mm diameter for connecting column to gusset plate, and 12 bolts for connecting cleat angle to gusset in 2 row. So as you can see in this book, the author has used the same strategy that I have talked about. Like here you can see the value will be the same that we have calculated previously, and the section is still the same. And the reason to use this same to same copy pasting in the exam for the section is because if you try to calculate manually, you are spending more than half an hour of what you will spend. If you spend it half an hour, then you are spending 1 hour. It takes more than half an hour to calculate everything manually, and no one is going to deduct